So our next speaker is Marmik Soni from Tessolve, who's a senior design lead. This is some work I did with him before I left Tessolve. And he's going to talk about AI-assisted design verification. He is at the center of the AI work going on at Tessolve, and that includes a lot of work on chip design flow, applying AI in chip design flow. And today he's going to talk specifically about design verification. Okay, over to you. Thank you.
Thank you, Mike, for the introduction. As Mike has introduced, today I'll be talking about the different aspects by which we can have the use of AI in design verification. So mostly how generative AI and different models that we are seeing in the market right now, how those can be leveraged directly to the applied solutions. So for that, we have a wide variety of solutions at Center of Excellence, Tessolve. And today I'll be covering few of them. I have taken one from the training aspect, one from the niche assertion generation, where we can take help of AI, and one on which we are passing the design specification and how we are generating different information. So those things I'll be covering. So it's a quick overview of the ecosystem that we have for the AI solutions for design verification. So this is the outline of the presentation, Tessolve AI strategy. And then after, I'll be introducing you to few of the tools out of different tools. The one is on the training part, which is UVM AI training tool. Assertify tool is there, and the Spec Extraction Tool is there. So these three of the tools we'll be talking about. And at the end, we'll be also talking about very quickly on the how the collaboration can be done with the Center of Excellence. So first of all, Tessolve's effective AI strategy. So different models we are listening a lot about the new models coming into the market, and the efficiencies, the benchmarks are scaling new heights every week, we can say every week or at least in a month, 3 or 4 times, we are seeing a big breakthrough in the market. Maybe it is the GPT models or the DeepSeek, or recently this week we have seen the Meta models. So we have kept the strategy by keeping the long-term vision where the models are replaceable. So whenever some new model is coming with some better accuracy claims on the benchmark, on the proven benchmarks, we can quickly adapt to those new models, and we can make the solution better. So that's the strategy. So we have our training data set. Normally, the framework with which the solutions are built at COE, I'll be showing that. So we have the training data. So we use that training data to fine tune the model, to make the model adapting our requirements. So then the testing is done with different user prompts, and those prompts sometimes are being converted into the form of buttons in our tools, where the dependency on the user prompt, we want to reduce those. So we are recording all the prompts also with all the solutions that we have. So with the model, we are getting the results. Those results are also being stored, and those are useful later on. So when we are having the mass data on the particular application, then we go for the automated test data, and we perform the validation in the particular application. Suppose one of the application where we have the solution is called ArcShift, where we are converting the codes. So we are setting up now the automated test data. Initial performance is good of the application or of the software that we have built. Then after, we go for the automated testing of the solution. So that gives us the clear efficiency of the tool and how reliable the AI solution is, or how what percentage of hallucination still is there in our solution, and how much more automated we can make it, reducing the human efforts, improving the timeline of the projects, as well as improving the efficiency. So this is how the strategy is. And as we talked about different models, So we are keeping all the user prompt, result, validation, use of model, fine tuning in a way that as we get some new model launched in the market, we can just plug and play with the new model, and that makes our overall solution strategy, uh, performance of the tool much better. And that takes maybe not more than 2 or 3 days of time to plug the new model and do all the basic scientific checking and to move with the new model. So that is, and even this thing is useful when we are having certain new application requirement from different technical teams. We can, with this strategy, we can at a time we can check with some 5, 6, 7 models, and we can check for our particular requirement, for our team's expectation, which model is performing better. So this is the overall strategy with which we are working. Uh, at the same time, when we are talking about AI, we have the security in definitely as a priority, and there we keep all the implementation models, all the AI applications restricted to our infrastructure, and that is we are making sure that the solution is quite secure and the specification or the client data or our confidential data is not being used and not being leaked for training the model. So similarly, we do the bot infra design, prompt expertise, model selection, model adaptation, AI infra migration, custom solution design we are creating as per the requirement, as per the niche requirement of the technical team. The access control, we have different methods for access control. Suppose it is to be used by a project team or internal to Tessolve or by client or some third party. We do have different mechanisms for the access control, and we also uh, do the we also supply the tools for the external teams, and we do the collaboration with the different R&D departments of different organization, and we support overall vendors scrutiny and many other things. So overall, all the everything about generative AI, machine learning, all the solutions are being provided by Center of Excellence. So this is the normal design verification flow that all of us are knowing mostly. So it starts from requirement specification, then feature list, coverage plans, test bench, different tests, then after the constraints and coverage we are following. So in that process, we have divided the complete flow in this steps. So feature extraction, then after the coverage planning, test bench generation, and that defines the test bench writing. So this is how the complete flow is associated with the processes. And the effort here in this slide is to show AI and automation can be helpful. So, sorry. Yeah. So you can see for this feature extraction process and coverage planning, we are using the AI application, AI engine we are using. We are also having the Python implementation where the scripts are there. Scripts are written in Python, which is helping on generation of the UVM test benches or writing the different test codes. Also, for improving the coverage, we are using the AI engine and also the machine learning models we are using for improving the coverage. And that includes a lot of simulations, debug, and regression suits also. So this is the overall flow and complete requirement to the coverage data, the complete design verification flow. We are doing the research on usage of generative AI, automation, and machine learning to improve the efficiencies, to speed up the processes, and improving the timelines. So a quick view of the ecosystem that we have. So being a stiff timeline department or expectation from the different teams and the application oriented approach, we can say. So we have the different bots being implemented, the infrastructure that we have used for the different applications, and at the end, what different set of applications we are having, a quick view over that. So when we are having the knowledge bots categories, there we know the features are faster to deploy and develop, but the uh, use cases are where we are not having much of the confidential data. No client projects are involved over there. We can internal usage. We can go for this kind of bots. Maybe it can be automotive functional safety assistant for the internal projects, or UVM training. For those kind of purposes, we are using this because the purpose here is faster deployment, low cost, and reasonable accuracy. By the same time, the compromise is on the security part. But if it is general data, if it is not much specific to the project, we can go for this approach. Otherwise, when it comes to the approach where our data is quite confidential or quite important, at that point we are doing the deployment, development through the clouds, and there we are having the client data which is highly confidential. The security is high, cost is a little high as compared to this, because here we are using we are just using the wrapper on the LLM models, and no further training is required over here. But here we have the all the development, end-to-end development, except model. Everything else we are putting, the prompt button, the UI, everything else we are putting of our own. So it is taking some time, but much more suitable for the project teams are getting a lot of benefits of this implementation. Sometimes when we are having highly confidential data and we want to go for the complete offline implementation of the AI solutions, we go for the maybe some of the popular models like Microsoft Orca or Llama. Those kind of models we are using for complete local implementation. And there the challenge is the adaptability. Suppose the scalability, we can say. So if the project size is getting growing, or the computational power is required, better computational power is required, or the bigger model is required, then we go for the higher infrastructure is required. So upfront cost is quite higher in this particular case, as well as the scalability is low. So cost is high, security is very, very high, and use cases when we have the highly confidential data. So that is the one front where our teams, COE teams are working to provide the solutions. So as a result of all this, we have wide variety of applications like DV spec analysis tool, the DV AI test bench tool, Assertify tool. Assertify tool is specifically for the generation of the assertions, writing the assertions, SVA assertions. I'll be briefing a little about that tool today. A few of the code converters, for example, we have a huge variety, half dozen of code converters are there where we are using generative AI extensively. For example, system Verilog to CocoDB code converters, or we want to go for Verilog to VHDL code converters, or in our embedded domain, we are having the ARM to RISC-V code converters to make the open source ecosystem more adapted to the embedded department. There we are also having the code converters. So similarly, domain and project-based AI fine-tuned models or application we are developing. So the team which is involved in the project will be only having the access, and they can leverage the generative AI application. Similarly, PDK training tools, UVM AI training tools, and I'll be briefing a little about this training tool after this slide. And also we have the code co-pilots also made available to the different teams. I'll be briefing today about three of the tools: UVM training tool, Assertify tool that you are seeing here, and the Spec Extraction tool. These three tools I'll be quickly briefing today. So this is the first tool. So obviously the UVM methodology is a complex thing for the fresher when he starts the career. So a lot of efforts are going into the training and grooming of those resources. So there definitely it's a direct use case where generative AI can do really a good job. So we provide the tool is having following options: organize the content, quick topics. So most important topics and their explanation the AI is doing here. MCQs, then MCQs for testing the knowledge, what understanding I have developed so far using the concept. So MCQs are there, frequently asked questions are there. So common and most important doubts it is resolving. Question and answer is the way we are having popularly knowing Chat GPT. Similarly, we have the UVM GPT. That is it is using AI model, and it is giving the flexibility to user to ask any questions about section and dashboards. So analytics, suppose I have some 20 engineers, what time the engineers have spent on the tool, how they are performing with the MCQ section, and what so each and everything analysis, what words they have used even while doing the query. So all those things we have implemented in this AI tool, and that is being used. So what are the key benefits? Self-guided and self-paced the flow. That's the key benefit when we are talking about the AI solutions. So less efforts or training to be training efforts and mentor requirement, and self-paced the flow they can be going through. Analytics and custom topic suggestion. The AI is also from the conversation, from the performance in the MCQ, the AI is also suggesting what particular topic on which the engineer is required to do some more work. Ask anything, as I said, UVM GPT. So anything as per your imagination, you can ask the questions on the verification, system log, or UVM methodology. Improved accessibility, it is available 24/7, as we know. Reduced training time. If you are good at learning the things at your pace, it will be reducing the time. Scalable for other domains. So this is just the UVM training. So we have trained specifically the model to answer on UVM only, but obviously we can switch it to the other domains also. Quickly, I'll be showing how it looks like. The UI is looking like this, and these are the different fronts on which I have explained in the earlier slides. Right, so you can see the UVM sequencer, it is explaining here, and the conversation continues. The context awareness it is continuously talking. You can ask questions on the given answer. So that is how it is looking like. It is quite effective, being widely used right now by the verification teams. So different features are there. MCQs you can see. So here it is giving the MCQs, and according to the answers at the end, when we are clicking the submit button, it will be giving the detailed analysis. The generative AI is giving you the report on what topics you should be putting more effort to learn, and like that. So it is a kind of complete tool, including the training, including the Q&A, and even the evaluation part, and the report being given by the generative AI quickly on the go. So the second tool I'll be quickly taking you through is the Assertify tool. We are so the problems around the assertions are growing complexity in the verification flow, human errors, time-intensive ask it is or time-intensive task it is, lack of consistency and skill gap. So different teams are working on assertions, maybe different projects. The skill gap or consistency can be the issue. So we are testing that at least we can take help of generative AI and generate the assertions from the spec or engineer's simple description using the AI models. That's the use case. And generate description from the SVA code. Suppose we have the SVAs written for some project, and we want to understand, someone is new and want to understand both the ways. We want to go for description to SVA, and someone is looking for SVA to natural language conversion. Both of these features are available in the Assertify tool. So as we can see, description to the SVA code, AI engine is at help over there, and the design signals are being taken from the top file also over there. So all the description that we are picking from the specification, the conversion into the SVA code the AI engine is giving, and it is using the design signals. So the SVA code which is being generated is obeying what the designer has used what in the top file. So that is part one of the tool, and the second part is the SVA code to the description. So there, according to the code, it converts into the plain English, normal natural language. It is converting it into that description, very easy, straightforward description for understanding of what the SVA code is expected to do. So this is how the tool is looking like. Quickly, if I show you. So the first part where we have the English description, natural language description to SVA code. So we'll have to just click simply convert to SVA code. Also, as I mentioned, here we are uploading the top file as well as the design specification. It is using that, and from that the code is being generated. The second part of the code where we are having the SV already available from some project, and if we want to give it to the give it to people for generating the description from that. So you can see copy, code, tooltip, and all the proper development we are having right now. And we are using this for assertion teams. It is working like this. You can see here the mapping details. The signal is mapped. This signal is mapped. So in the, you can see AW valid is written over here in the top file. AW valid is written as the AXI underscore AW valid. So it is using that in your generated code. So this is how it is taking care, in short, uh, of the design top file, and it is generating the assertions. Just a second. Okay. Fine. So in short, it is, as I mentioned, it is taking care of the mismatch between the English description and the top signal file, and it is using the proper required signal. So that is, this is a table taking care of all these approaches, all these mismatches, and it is giving you the proper assertions. So again, from the code, it is giving you the English description. So I'm not going much into the detail. I have some 7 minutes left. So Spec Extraction Tool, this is the third tool which I wanted to highlight out of our whole range. So here we are using the RAG approach, retrieval augmented generation approach, for this spec extraction. So the design verification flow, as we know, starts from the chip specification. So here the input is becoming the project spec or the training data prompt, what base prompt, what character you are trying to give to the AI solution, the user prompt at the time of real time use, and the LLM intelligence, whichever model is performing best or whichever model is latest and you want to use, that is being used over here, and the output is there. So this is how the RAG solution works. This is the block diagram of that training data. This section is fixed yellow section that you can see. So the training, the data related to the project, particular project, the user input. Sometimes it is prompt. Sometimes we are also keeping the buttons to remove the dependency on the user prompt part. And then after, it is using the base prompts and using the LLM for restructuring and passing the PDF and generating the responses. So this is how the spec extraction tool works for the different application. So how we do actually, the spec from which we start, then the model benchmarking from the available different model, plug and play, and we choose the model which is working good for the expectation for that particular project. Prompt and response recording, as always, and a filtering by the manual validation. So initially we do the manual validation, and then we are keeping the, for example, the tester plan. For example, the test plan we are keeping in the Excel sheet with confidence score, how confident the AI is on that responses. So all these things are being recorded and being given to the design verification engineers. So it's, for now, we have seen even up to 60-70% improvement at times on some of the projects. So this is how it looks like. The normal the specification is being uploaded over here. The questions are being asked. The models we are having at the back end, which we can select from different, and this is how it responds, which is useful for creating the test plan. I'll be quickly moving further. So also we do the RAG assessment. It is not like we are having the RAG and we are completely relying on that. We have the RAG assessment framework also. There we check the faithfulness, context recall, context precision, answer relevancy, everything we are regularly checking to make the solution better. So RAG, the first part is retrieval, second part is generation, and there we are checking both the sections, both the parts of the solution by these 4 parameters. And this is how the normal testing looks like. 1 is there for the best and 0 is there for the worst. So the question and answer, the golden responses are given in the RAG assessment framework, and there it is giving that, okay, this RAG solution that you have implemented is this much close to the golden response, and accordingly it will be giving us the 4 parameters to claim that, okay, this solution is quite appropriate and better. So there I'm about to complete my presentation. So collaboration for the DV flow. So these are different fronts on which our teams are, COA teams are working right now. It's starting from test plan generation, test cases, assertions. Today we have covered a little. Tool integration, automated validation, different AI agents for the DV flow task, unit test bench generation. All of this we are doing, and suppose you are interested to have the collaboration with us and do the research together, we are happy to do that. These are different research fronts on the AI part. AI agents, we are doing a lot of work right now. AI guided training, you have seen one flavor of that today. Chatbots, automation, generative AI strategy, generative applications, model building, all these things are around the AI research. So we are happy to collaborate and engage together. That's it from my side. Maybe we can have a quick look. Mike, you can have a look at the questions.
Okay, thank you very much. Thanks, Mark. And yeah, thank you for stepping in a bit early. Any questions here? Then I'll just quickly check online. So one question from the audience there. Go ahead.
Just a simple question. I mean, what's the all that can be done by tool or ChatGPT already? So what specifically is the sales pitch on this?
So the question is, Mark, this can be done mostly by ChatGPT already. So what
yeah.
are the advantages to be given?
Yeah, there are few points, but the key and two main points which I'll be highlighting over here is the training data. Suppose one definition that you want to use for your project. Maybe there are 10 different versions which ChatGPT will be responding when you are directly interacting to that. And here the responses are according to your training data. So that is the difference number one. The second difference is the most critical part whenever we are talking about the project is the confidentiality. So there are the huge possibility that whatever data or whatever interaction you are doing with ChatGPT directly, the data is leaking over there. Okay, so we never know how the data is being used for training purpose. So these solutions are in-house, secure in our cloud or offline infrastructure that Tessolve premises that we are having. So that's the key difference. So leveraging the power of AI models and doing the integration for different task applications, making it automated with buttons. Those things are not, those are just the chatbots, and those are chatbots with no guarantee on the data part. Here it is not about just the chatbot, it is about also the tools and buttons and automated actions and validations. So a lot of other things are there.
One more question, two more questions. Go ahead.
So what base model did you use?
What base model
did you use? It's not same.
Which base model?
Can someone repeat the question, please?
Sorry. Sorry. Which base model did you use?
Mike, it depends on the different applications. Number one, for suppose coding, we have benchmarks available. So for coding, certain models are doing good. So we use for code conversion certain models. For suppose for some other applications, we do the benchmarking. So we use some testing of some 5-6 models. And in general applications, suppose UVM training or something, the OpenAI models are behaving good over there. So it depends on use cases, but if we take the training rated stuff, then OpenAI models are good enough.
Yep, go ahead. Sorry.
So if you're using third-party models for ChatGPT, will it not be a security problem? So information leakage, for example, with time of that.
Yeah, so the question about security of ChatGPT,
Mike, can you keep the microphone closer, Mike?
The question is, how do you make sure that the data is secure, or the ChatGPT is?
Yeah, so let me, okay, how the data is secure, what is the guarantee? That's the question, I think. So two things are there. Some of the models that we are using are completely offline. So even in simple words, if I say, even the machine is not having the, suppose I'm implementing locally in my system, even without internet, it will be working in a single baseline answer. Some of the models where, suppose, for example, OpenAI or some other models, we use the cloud encryption over there. So cloud services like Azure or AWS, those kind of services we use, they are having their own security layers. They are having their own guarantee on the data part. So those also can be used. But obviously, these options are much better or much secure as compared to directly interacting with the ChatGPT or any other models.
Okay. And the last question from the audience here.
Studies on custom in-house IPs. So
Have you got any case studies on custom in-house IP where you've used this?
Yes, Mike, we have used this for the projects. We have the use cases where this is being used for the project, like.
So the comparison is against something that's very popular, for example, AXI and AMBA protocol, which is publicly available. So the LLMs would perform well on data that is very popular and publicly available. Contrast it to something that's very specific to a very specific client. That's the comparison.
Yes, have you compared what's the performance of this on publicly available models versus in-house IP?
Uh, uh, Yeah, we do it, but it is specifically for the particular use case. We have the internal technical competence team is there, so they have done the comparison. And sometimes we have got not the really great outcome, so we are trying to improve on that. But many of the fronts are there where we have really good outcome of these solutions. And we have, obviously, we do the benchmarking with the manual processes also, and with our AI solutions also, with the open available solutions.
Okay, thank you. I think we'll go for a break there. So thank you